So today we're going to be talking about how to graph parabolas that are in standard form. So let's go ahead and get started. So here are some of the things you will learn. First of all, we should know that standard form is y equals ax squared plus bx plus c. There is a different form we're going to be talking about later on, but that's standard form. You'll be able to look at standard form and be able to quickly determine where the vertex of the parabola is. So if we have a parabola, we know that the vertex is the bottom point. So you'll be able to identify that bottom point. You'll be able to identify where the y-intercept is. And so if we have a graph, let's say that looks something like this, we'll be able to figure out where the y-intercept is at. You'll be able to figure out where the axis of symmetry is located. So it's either going to be x equals 1 or x equals 2 or x equals 3, but it's going to be some vertical line. Could be x equals negative numbers as well. We're going to be able to figure out what effect on the graph does the a value have. That's an important value when we're looking at the graph. And you will learn that the a value that are positive will be like this parabola that opens up. But if the a value is negative, it will be a parabola that opens down. And then finally, we're going to learn about the c value. The c value is another important part of this function because it will be connected with the y-intercept. So all those things are things we're going to explore and learn about today so that you can graph these pretty quickly on your own by hand without your graphing calculator. Let's go ahead and get started. Do you remember this equation? Y equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I know you're probably wanting to sing that in your head, but there's some important parts to this function that we're going to use to come up with the graph. And so we know that the graph of a quadratic function, by the way, this function works whenever you have an equation that's in standard form like this, y equals ax squared plus bx plus c, but it's a way to figure out what x is when y is 0. And so it is related to a parabola, which you see here. And so one thing that we want to be able to do when we graph these parabolas is we want to be able to figure out where the axis of symmetry is at. Because if it is located on a graph way to the right, those are the numbers we're going to plug in. If it's located way to the left, then we're going to plug in numbers to the left. Otherwise, if it's way over here to the right and we plug in a bunch of numbers to the left, we might get points that look like that, but we really won't know what that parabola looks like until we get the axis of symmetry. That's going to be in the center of our graph. And the equation for that axis of symmetry is the part of the quadratic formula that's the negative b over 2a part. And so that gives you the axis of symmetry. So here's the a, the b, and the c. If we just take the negative b over 2a, that gives us the equation for the axis of symmetry, or where it's located on the x-axis. Then we have values to the right and values to the left. Like the plus b squared minus 4ac gives us a point to the right. The minus b squared minus 4ac gives us a point to the left. And so that's why the negative b over 2a is in the middle. That's going to be an important concept as we get started graphing these functions. Let's go ahead and start looking at this particular equation. We have an equation in standard form that's y equals x squared minus 4x plus 3. Well, let's just go through some of the steps so that we can graph this. We could just make a table of xy values and plug in just random points for x, random points for y until we think we know what the parabola looks like. But it's going to be really helpful for us to start by finding the axis of symmetry, so we know where on the x-axis this is going to be located. And so remember, the axis of symmetry is just negative b over 2a. And so in this particular example, the b is negative 4, so it's going to be positive 4 over 2 times the a value. And the a value here is 1, so it's 2 times 1. Well, that's 4 over 2, which is equal to 2. So that means my axis of symmetry is going to be at x equals 2. So somewhere along this line is my axis of symmetry. And if I'm going to make a table of values, my center point is going to be 2, which means I can plug in other x values like 1 and 0 and 3 and 4 because those are all located around the axis of symmetry. Okay, so let me get rid of this stray mark here. So what we want to do then is we want to figure out where on this axis of symmetry is the vertex. So I don't know if the vertex is up here around 5 or around 3, or maybe it's down at -2 or -5, but it's somewhere along this line. And so that's the y value. So I simply want to plug in the 2 into my equation to figure out what the y value is. So if I plug in 2 up here, 2, it's going to be not x squared but 2 squared, which is 4, minus 4 times 2, which is -8, plus 3. And so 4 minus 8 is -4, -4 plus 3 is -1. So that means my vertex is right here at -1, or 2, -1. So there's my vertex, 2, -1. Well, let's move on in this process. The next thing I might want to figure out is whether that vertex is a maximum point or a minimum point. So that is going to be determined by whether the parabola opens up or down. If it opens up, then that point is a minimum point. If it opens down, then that vertex is a maximum point. And so we've talked about this in class already, but one thing I want to point out is this a value. Anytime the a value is positive, it's going to open up, which means I know this parabola is going to be opening up somehow, but I don't know exactly how fast it's going to be opening up. And so as I plug in the rest of these points, in the back of my mind, I'm just going to be thinking, okay, this better be opening up as I go through this. So let's take a look at some other points that we might find out. Can we locate the y-intercept? The y-intercept is a really easy point to find by looking at the equation in standard form. We find the y-intercept by plugging in a 0. And so whether or not it shows up on our table or not, we can plug in a 0. And whenever we plug in a 0, the quadratic term will be 0, the linear term will be 0, and so y will always equal the constant term. So that constant term is always going to be our y-intercept. So our y-intercept is up here at 3. And assuming that we got that's the point 0, 3, assuming that we got the axis of symmetry correct, we then can get another point that's reflected over that at 4, 3. So we have now 3 points on the graph, but we want to come up with at least 5 points on the graph. So there's 2 obvious points here that we could now find. They should give us the same y value because they are reflections of each other. If I plug in a 1 into my equation, I'll have 1 squared, which is 1, minus 4 times 1, which is -4, and then plus 3. And so 1 minus 4 is -3, -3 plus 3 is 0. And I would get the same thing if I plugged in 3. So I have a point here, and I have a point here, and my parabola looks like this. So these 5 steps are going to be really important, I think, for graphing parabolas in an effective way that are given to us in standard form. Let's take a look at some more opportunities to practice these. Let's start with this first equation. Y equals x squared minus 4x minus 2. So what I would like for you to do right now is to go through those steps on your own, pause the video, graph that equation, and then start the video back up and see if you got the same thing that I came up with. So hopefully you've done that, and now we want to just take a look and see how I was able to graph this equation. You should have negative b over 2a is the first step we're going to do to find the axis of symmetry. So negative b is positive 4 over 2 times a, that's 2. So 4 divided by 2 is 2. And when I plug that in, 2 squared minus 4 times 2 minus 2, I get -6. So I have the axis of symmetry right here at 2, and I have the vertex at 2, -6. I also know this opens up because the a value is positive. I know that the y-intercept is at -2, which is right here. And because that's at -2, I have another point right here at 4, -2. And so that's these 2 points, 0, -2, and 4, -2. And if I plug in 1 and 3 with both of those values, I would get -5. And so that's this point here and this point here. And my parabola is going to look something like this. Hopefully you got that. If not, hopefully we figured out what we did incorrectly. Let's take a look at this second equation. So it's a little bit more difficult, I think, this one, because we have a different A value, a little bit different of a parabola. But go ahead and pause the video right now and see if you can graph that one on your own, and then you can start the video and see if you have it correct. So hopefully you were able to do that. And let me just go through some of the work that I did here. I did negative b, which is negative 4, over 2 times a, which is negative 2. Well, that ends up being negative 4 over negative 4, which is positive 1. So that means my axis of symmetry is at positive 1 here. And then if I plug in positive 1, I get negative 1 back out. So that's my vertex. I also know this parabola opens down because the a value is a negative 2. I could find the y-intercept is negative 3 because if I plug in 0, I get negative 3 here. And because I know that is a point on my graph, I also know this is a point on my graph because they're reflections of each other. And so if I were to plug in, let's say here's 2 and here's 3 and here's 0 and here's negative 1, I know that if I plug in 0, I would get, if I plug in a 0, I get negative 3. And if I plug in 2, I get negative 3. So those are 3 points. So then I'd have to plug in either a 3 or a negative 1 here. And if I plug in a 3 or a negative 1, I'm going to get a negative 9 in both cases. So that's off my graph, but you can see that those would be down here, and my parabola would look something like this. So if you didn't get that one right, hopefully this third one would be a charm for you. Let's now take a look at this third equation here. And what I would like for you to do is to go ahead and see if you can graph this equation here with negative x squared plus 6x minus 5. And then you can start the video and see if you got it right. So here's the equation without all the markings on it. So hopefully you pause the video and are able to look at some of the equations on your own. But let's do negative b over 2a. It's going to be negative 6. So negative 6 over 2 times a. Well, that's 2 times negative 1, which is negative 2. So that means we are at 3. So the axis of symmetry is right here at 3. Well, we want to be able to figure out what the y value is. So if I plug 3 in, it's going to be negative 3 squared, which is negative 9, plus 6 times 3 is 18, minus 5. So negative 9 plus 18 is 9, and 9 minus 5 is 4. So my vertex is going to be right here at 3, 4. This does open down because the a value is negative. The y-intercept is negative 5, which is way down here, which means I'm going to have another point at 6, 5. So those are kind of far apart. So if I were to have a table of values, I probably wouldn't have included those, but I can. In this particular case, I have a point here in the middle at 3, 4. I have a point at 0, negative 5, and 6, negative 5. And the rule is I need 5 points. So maybe I can plug in a 2 and a 4. Those are the same distance away from the axis of symmetry. And if I plug in a 2 or a 4, I'm going to get a 3 in both instances. And so I'm going to have a point here and a point here. I could also, if I wanted to, have plugged in a point like a 1 and a 5. And if I plug those points in, I would get a 0 in both cases. And so now I actually have 7 points for this graph. And my parabola is going to look something like this. So hopefully this has helped you figure out how to graph parabolas. Let's move on to one last example. So it says, suppose the following equation models the percent of people in a certain age that either cause an accident or get a driving violation. So we want to know what age people are the safest drivers. Well, this is going to be a parabola that opens up like this. It's probably going to be something that looks similar to this. We want to figure out where the axis of symmetry is at and where the vertex is at. And so we're going to do negative b over 2a. So I want to find the vertex. So I'm going to do negative b over 2a. Well, that's 3.2 over 2 times 0.04. And if I evaluate that, that gives me a value of 40. That means if your age is 40, you are the safest drivers. The worst drivers are probably the younger ones and the older ones. So good luck.